This is an introduction to exercise 7.8 on applications of integration on page 317, thank you, of the textbook. I want to start with the average value of a function. We'll move on to our worded problems using integration, and then we'll move into integration by recognition. Okay. The first thing that we need to note is the formula for the area, so not the area, the average value of a formula. So if we have the average value, please copy this down somewhere in your book. Average value from A to B, inclusive, there we go, equals the formula being 1 over B minus A, assuming that it goes from A to B, so B is greater than A. I'm going to rewrite that a little bit nicer. There we go. Multiply by the integral from A to B of our f of x dx. Average value from A to B is 1 over B minus A multiplied by that. Now, it makes sense to say that if I have the average value, I can find the area on the inside and divide it by that difference, right? Divide it by the width, right? That'll give you average value. Think about it as like a basic, like a rectangle. It's the same idea applies. Now, the mistake that commonly gets made in the exam, which hurts my soul every time I see it, is average value versus average rate of change. A lot of students just see average and it's related to calculus, therefore I'll use one or the other, interchangeable. They're not interchangeable. Your average value is saying that if I was to draw a line, a straight line perfectly across, that is the average y value, that's what this is. Your average rate of change is saying that if I was to calculate all the rate gradients and then put them all together and average it out, that's what the average rate of change would be. In other words, that's your m equals to y2 minus y1 over x2 minus x1. They're very different things. This one is notably more difficult, not because it's very hard, but because the other one is something they've done since year 9. In this question, it says find the average value of f of x equals to x squared for the interval 0, 2. Illustrate this with a horizontal line determined by this value. So I'm going to go a little bit backwards just because I'm teaching you this process, but I'm just going to sketch the function first and then show you what I'm looking at. So our general function, of course, will just look like an x squared. I'm just going to draw the right-hand side, the positive end of it, because its domain is 0 to 2, which would look something like this, of course, this being 2, 4. Now, with that in mind, the average value is saying that if I was to get every single y point here and add it all together, and divide it by the number of points, what would the y value be? Now, it makes sense to say that because this is even though the height is 4, because this is a parabola, you're not going to have it exactly in the middle. It's not going to be exactly 2. So it should be, theoretically, perhaps slightly below 2. That's just an estimate I'm making, right? Because most of your points are below 2, so it wouldn't make sense for them to be the average to be above 2. But let's just do this mathematically. The average value, I'm going to apply my formula. Average value equals, I'm going to go 1 over 2 minus 0, multiply by my anti-differentiation from 0 to 2 of x squared dx. To speed up the process, I'm going to assume that you know how to do this and just write out the calculation. Of course, remembering that you don't need your plus c because it is a definite integral. So after calculation, you know your anti-differentiation integral, etc., you end up with 4 over 3. Now that aligns with my estimation. The average value of a function is just using that formula. Again, please don't get this mixed up with average rate of change. For context, your average rate of change is, and don't write this down, but your average rate of change between, for example, this point and this point is to calculate the gradient of that line. That's what the average rate of change would be. So they're very different. Don't make that mistake. Any questions?
So with it says illustrate this with a horizontal line, would we just guess where 4 and 3 was and just draw a line?
So normally you'd go backwards. So you'd calculate it and then draw the line. Thank you for noting that. So you'd normally calculate it, then draw the line, but in this case I was just doing an estimation. But yes, you're correct. Jenny. Alright, I'm going to move on to question 13. Am I going through it too quickly? Okay. Question 13 says, a stone is projected vertically upwards from the top of a building at 20 meters high with an initial velocity of 15 meters squared. Page 26. Find the time taken for the stone to reach its maximum height. There is a bit of information here that is not explicitly written, but it's something that you need to know. For those of you that do, does anyone here do physics? Okay. For those of you who do physics, what is the gravity's acceleration? Negative 9.8 meters squared. For maths, sorry, meters per second squared. For math methods, we assume negative 10. Don't ask me why, that's just a number they've picked. We're going to assume negative 10. I know it hurts all of you that do physics, but in most circumstances where the question uses kinematics, they'll state the acceleration, otherwise assume negative 10. So you're going to write down here, acceleration equals to negative 10 meters per second squared. A reminder that acceleration is how fast or how long it takes to get to a certain speed as opposed to a certain distance. That would be, of course, just your speed. Let's do our calculation. So acceleration is negative 10 meters per second squared. Our velocity, of course, is our actually, I'll write this out here. Our acceleration, velocity, and displacement. Typically speaking, we use x for displacement. I don't really know why, but that's just something we do. So, for example, when I go acceleration to velocity, we integrate. Same thing for this way. And if I go this way, from displacement to our velocity, we differentiate. I'm just going to use these symbols here. I'm going to assume that you know what I mean. So to get from acceleration to velocity, I'm going to anti-differentiate the formula, which is negative 10, and I'm going to use t for time, t plus c. The c is imperative in this scenario. There's another bit of information that's key here that we haven't used yet. How do I find the value of c? Is there a pointer we can substitute in? So we can substitute t equals 0. So in other words, v of 0. What is v of 0 equal to? That would be displacement. Well, v of 0 is the initial velocity, right? And it states the initial velocity is 15 meters a second. So v of 0 is 15, which is also c, because if I substitute t equals 0, I get c. So my formula for velocity is v equals to negative 10t plus 15. Now, let's actually do the question. The time taken for the stone to reach its maximum height. There are two ways you can think about this. The first way to think about it is to say that, well, if we've got our displacement, the way it reaches the very top, or the maximum height, is to differentiate the function and then let it equal to 0. So I could just use this function because the velocity is the differentiated displacement. So v of t equals 0. I should write let. Let v of t equals 0. That's negative 10t plus 15 equals to 0. Plus 15 equals 0. Therefore, t equals to 1.5. If you write this in the exam, you will not get full marks. Therefore, 1.5 seconds. I know, it's pedantic, but depending on how the exam is and how everyone else performs on the exam, it's a stupid mark to lose. Now, so to find the maximum height reached by the stone, in this case, we actually do need to find the displacement formula, which in that case, remembering that our displacement formula, x, is the integration of our velocity, which means that x of t equals to, I'm going to anti-differentiate that, which I'm assuming you're comfortable with. I'm just going to write negative 5t squared plus 15t plus c. There is a point that we've been given as well. It says that it starts from the top of a building, 20 meters high. So x of 0 equals to 20, which again is c as well, because if I substitute 0 for t, I end up with c. Therefore, x of t, our displacement, is negative 5t squared plus 15t plus 20. What I'm going to do now is something that you don't need to do, but I'm just putting into the calculator's graph to visualize it. So in my calculator, and I'm going to open this up in a larger screen. There we go. I'm going to go to my menu, my graph and table. There it is. Graph and table. I'm going to put in my function. So I'm going to put in, what did I say? Negative 5x. Remembering that you need to put in your x instead of t. Negative 5x squared plus 15x plus 20. Are we aware how to restrict the domain of a graphing function? Have I gone through that before? So in your keyboard, which my keyboard is missing. Here we go. In your keyboard, if you go to Math 3, that's tiny. If you go to Math 3, there is a given that symbol that you use in probability. So given that, and I'm just going to put in, because of course time can't be negative, so I'm going to put in x is greater than or equal to 0. Just to restrict it a little bit easier. I graph it. That's what my function looks like. Okay. Now, our function, of course, is from the top of a 20-meter building, but we're throwing it up vertically. Keep that in mind. So it says find the maximum height reached. Of course, we can find it by substituting our 1.5 from earlier. So x of 1.5 would equal to 31.25. I'm just skimming ahead. Again, therefore, 31.25 meters. Now, the time taken for the stone to reach the ground, this one is worded a little bit interestingly. Now, from my perspective, there is only one word that changes the response entirely. Remember, the stone is projected vertically upwards from the top of the building, 20 meters high. In my mind, the question's asking for what is, because it's saying time taken for the stone to reach the ground, what is the x value or the t value that my y, or my function, hits the x-axis. So what is my x-axis intercept? However, that is not correct. The reason it's not correct is because the question says thrown vertically upwards. So this person, for some reason, is throwing a stone, throwing it up, and waiting for it to hit the actual building again. It's not actually reaching the ground. So the words vertically upwards is key here. We're not looking for what our x-intercept is. We're just letting x of t equal to 0. Solving that gives you -1 or 4. Of course, to get full marks, you need to exclude. T cannot, actually, let's rewrite that in mathematical terms, is greater than or equal to 0. Therefore, t equals to 4 seconds. I probably should rephrase what I'm saying. Let me rephrase that again. We are looking for an intercept there, but we're not looking for it when it hits -20. My initial thought is that the building falls off the rock falls off the building, hits the ground that is 20 meters below, therefore we substitute -20. No, my apologies, we are substituting, letting it equal to 0 to find the intercept there. So, again, it's that point there. Let's move on. The velocity of the stone as it hits the ground, now that we know the value is 4, all we have to do is substitute that back into my velocity formula. So V of 4 equals to -10 times by the 4 plus the 15, which gives us an answer of -25 meters squared. Now, it's not a question that's going to ask right now, but what does that negative imply? It's traveling down, that's it. If the question asks for speed, which I highly doubt the methods exam will, but if the question asks for speed cannot be a negative value, right? Remembering that when you reverse your car, your velocity is negative, but your speed will always be positive. Any questions? Up the back? Any questions? Okay. Question 14. Turn the page for me, thank you. I'm going to try and stick to using the left side of the page because I want to try to use the second side of the page, the right-hand side of the page, to put in my two different questions. But the rate of change of temperature with respect to time of a liquid which has been boiled, then allowed to cool, is given by dt over dt, where capital T represents temperature and little t represents time. We have a function -0.5 t minus 30. Sketch the graph of dt over dt against t for t is greater than 30. So, again, very basic graphing. You can just do this in the calculator, really. There's no need for you to have to do this by hand. It just looks like that. Pretty easy. And this, of course, is for dt over dt. And that'll be it.
What are the axes there?
Good question. So this is dt over dt. So this, of course, is t. This value right here would be, because we're looking at a negative, well, actually, it's actually just a linear equation, isn't it? So this would be our capital T.
So the x-axis.
Oh, sorry, that should be a little t. Probably should have picked different variable pronumerals there. Okay, so sketch the graph of dt over dt where it's inverted. When we find the reciprocal, all we have to do is have our function, original function, and we flip it. So in our original function, that equals to negative, and I'm just going to write it out as 1, actually, let's write it out as t minus 30 over 2. Right, that's our original function. In our reciprocal, it's going to equal to this. Negative 2 over t minus 30. I've just written the reciprocal of it. Again, just sketch this in your calculator, and you end up with this function here. Right, that is continuous from that point onwards, where this is 30. That's not particularly the focus of this question. What I'd like to focus is question C. Find the area, correct to 2 decimal places, the region enclosed by the graph of B. Why is there a... Oh, question B, sorry, that's what it means. The graph of the one that you draw in question B, the x-axis and the lines t equals 35 and t equals 120. I'm just going to add these in retrospect. So it will say this is 35 and this is 120. Of course, it's not accurate, it's not to scale, but it'll do for now. Of course, the area is going to be given by area equals to a negative. I'm using the negative because it's under the graph. From 35 to 120 of our function, negative 2 over t minus 30 dt, which I've just put in the calculator, which gives us an answer of 5.78. What does this area represent? Now, you've got your time, your rate of time, changing depending on the rate, depending on the temperature. So when you do this area, you're integrating. When you integrate, the area represents the time taken for the liquid to cool from 120 degrees to 35 degrees. Remembering that your area is your integration, so the same idea applies. If you're anti-differentiating or integrating your derivative function, it'll give you your original idea. So what is changing depending on what? Okay. Are we happy for me to move on to the questions that are not in the booklet? Yeah. Hopefully it won't be too much longer. I'm just going to arrange this component here. Okay, so I'd like you to copy this into your notebook, thank you. We are going to start with a new new component. It's called integration by recognition. I'll write the question out, and then we'll solve it together. That's the question. Find the antiderivative of 1 minus half x to the power 7 dx if y equals to 1 minus half x to the power 8. No calculator question. Are you happy for me to start going through it? So in this case, we need to identify what we need to do. I'm going to show you the process, and we'll go through another example after that, a similar question, but we'll go through the process after that and see if we can identify the steps involved. I'm going to write dy dx first. So dy dx equals 2, and I'm just going to apply my chain rule. So that's 8, 1 minus half x to the power 7 multiplied by, and the derivative of the inside function, which is just got to be negative a half, which gives me negative 4 bracket 1 minus half x to the power of 7. You will know very soon, why this is called integration by recognition. Okay, so the derivative of y is that. Okay. Well, if that's the case, I can say that the antiderivative of whatever I've just written, so negative 4, and you know what? I'm going to take out the negative 4 now. Negative 4, 1 minus half x to the power of 7 dx equals, and because I'm anti-deriving the derivative, it just equals to y, doesn't it? I'm going to write plus c, because we're not doing an indefinite integral, so plus c. Now, I know the goal is to find, oh geez, that's not what I want to do, here we go. I know the goal is to find that. So to find that, I need to try and make my original antiderivative look like that, the only difference being the negative 4. So let's just divide both sides of my negative 4. 1 minus half x to the power of 7 dx equals to, and I'm going to divide everything by negative 4, so that becomes negative 1 over 4, 1 minus half x to the power of 8, and instead of having to write minus c over 4, I'm just going to write plus c1, because we don't know what c is. So I'm going to write c1, it's a different value. That's it, we're done. That's integration by recognition. I've already solved, right now, I've solved what this is. Right? That's the same as what I've highlighted above. That's what the integration is. But you can see how that process is a lot quicker than having to go through full expansion and then whatnot. Yeah? Or, if it's a more complex equation, having to avoid those tricky ones that you can't really do by hand, it's impossible to do by hand. I'm going to give us one more example. It's a little bit of a similar one, but I'll give us another example. I'm going to write it down. You know what? I might have to scroll somewhere else. I'll scroll to a different page, and then I'll get us to write it down whatever space you have. I'll flick back to that one later on. Okay. Let's use this space. So, it's a two-part question. Again, it's still recognition. Let's say question A says find dx of bracket square root x. And B is to find from 1 to 2 anti-differentiation, that should be an x dx. Okay, so first one's very easy. It's just your standard differentiation. Just make x square root of x into x power of half, and I'm assuming that we can I'm just gonna write it out because I'm assuming we're okay with that. Dx of our square root of x equals to 1 over 2 root x. That's just your standard differentiation. Now for part B, if that's true, then the integral, I'll zoom in a little bit, the integral of 1 over 2 root x dx equals to the root x plus c. Correct? I'm just going backwards. If I differentiated it, now if I anti-differentiate it again, it's just going to give me the original value, of course, plus c. Any questions about that process? That's very key in this step. Okay. The difference between my original question, the 1 over root x, and the 1 over 2 root x, of course, is the 2. So let's take out the 2. So I'm going to, well, of course, if you think a couple of steps ahead, I can take out a half and then times everything by 2. Okay? So that gives us root 1 over root x, so not root, integral of 1 over root x dx equals to half, oh sorry, not half, 2 root x. And again, instead of writing 2c, I'm just writing c1. Because the c is ultimately irrelevant here. Any questions about that? I've kind of skipped the step there. Okay.
So then where are you getting the 2 from?
So because from here to this step here, I can say that the first line is the same as saying half multiplied by the integral of 1 over root x, correct?
Mm-hmm.
And then I can just times both sides by 2 to get rid of the 2 completely. Yeah? Does that make some sense? From there, because the question is just asking us to do from 1 to 2, I can just say that if I go from 1 to 2 of 1 over root x dx, it's the same as saying doing the definite integral of 2 root x from 1 to 2, which I'm assuming you're okay to do from there. The rest of it's identical. Ooh, long video. Any questions?